Go to now miscellaneous exercise 8. First question, find the area under the given curves and given lines. So here see the first sub question. You have parabola, lines x equals to 1, x equals to 2 and x-axis. This is very standard formula based question. So area equals to modulus of I, where I is given by integral 1 to 2 around x-axis, so dx, y dx, you know the formula, 1 to 2, what is y here, x square dx, so x cube by 3, standard integral 1 to 2, 8 minus 1, so we'll get the 7 by 3, this is I, and therefore a equals to again 7 by 3. If you want to just see the required ration, so here these are the two coordinate axes, x-axis, and here we have y-axis. This is the parabola. This is x equals to 1 here and x equals to 2. So this is the required ratio, remember, just for your information. X equals to 1, x equals to 2, remember 1 to 2. This is the required ratio. Okay. What about the second sub question? Same, you can just do the same way. Area equals to modulus of I, where I is integral from where to where? 1 to 5 y dx, that's x raised to 4 dx, and just complete it. Think about which is the required ratio here. Okay, question number 2, second question, find the area between the curves. So your curves are this, between the curves y equals to x and y equals to x squared. You know that this is a straight line and this is very standard parabola through origin. Standard parabola, you know. Okay. What about the rough region here? If I just show you, these are the two coordinate axes here. This is a parabola symmetric about y-axis through origin. Origin satisfy this equation, you can see. And y equals to x is very standard line, 0, 0, 1, 1 and so on. Bisecting the first quadrant, this is the line. Okay, this is y equals to x line, very known standard line, you know it. So what's the required ration? Required ration is this. Now whenever you have area between two curves, you know it starts from here, x equals to 0, it ends here, that you need to get. How do we get this? By solving these two equations. So solve the equations. Solving equations. If I solve the equations, compare these two, x equals to x square. So x into x minus 1 equals to 0. So either x is 0 or 1. 0 तो ये आपने लिख दिया था, 1 is this. So now this become x equals to 1. This is now 1. So integral from 0, area equals to I, where I is integral from where to where? 0 to 1. 0 to 1. Here dx, one function minus the other function. One function means y, so you can write x square, minus the other function, that is again y dx, remember. Now integrate it and simplify, so we'll get the required answer. Just question of simple integration. Fine, I hope this you can do. This is very well known standard question. Question number 3, find the area of the region lying in the first quadrant. Okay, so you want the area in the first quadrant, bounded by y equals to 4x squared, then x equals to 0. This means, you know, y-axis, x equals to 0 means y-axis, y equals to 1, y equals to 4. So here limits are around y-axis, remember. Now let's see the region here, which region you want here. So if I just show in a rough diagram, x-axis, y-axis here. Parabola is symmetric about y-axis. Why? Because y variable is free from the square and it passes through origin. So parabola would be like this. Parabola would be like this. And this is x equals to 0. That is y-axis. Then y equals to 1. So if this is y, then this is y equals to 1 line. Horizontal line, remember. This is which one? Y equals to 4 here. Y equals to 4. So this is the required region. It's around y-axis, remember. Limit starts from 1, its end at 4. So integration won't be difficult for you, remember. So here area, that is A equals to modulus of I, where I is given by integral from where to where? 1 to 4. Around which axis? Y-axis. So I'll write dy. When you write dy, you need to write x. So x dy and y dx. I have already told you a number of times earlier. dy लिखो तो यहाँ पे x लिखना है. Now you know this. You need to make the x as a subject of the expression in the function. Right? So what you will get from this? You will get root y by 2 from the function. Right? Y equals to 4x square. So what is x from this? Root y by 2. And q positively, normally when you take the square root you are plus or minus, but here it is in the first quadrant, remember. Isliye positively. Now just integrate this. Y raised to 3 by 2. Raise the power by 1 divided by the same number. Limits from 1 to 4. 2 will get cancelled. 1 by 3. 4 raised to 3 by 2 minus 1. Square root of 4, 2. And then cube. So 8 minus 1, 7. So 7 by 3. So here area equals to 7 by 3 units. If you want, you can write. Question number 4. Fourth question. Let me do here only. Question number. I'm sorry, this was third question. Okay, so this is question number 4 now. Sketch the graph of this function. अच्छा, y equals to modulus x plus 3 and then आपको integrate evaluate करना है. You know this very standard well-known function. This is a modulus function. If you want to draw the graph, you can just take the tabular values like 0, then 3, 1, then 4, 2, then 5. 0 already taken. Let me take minus 1, then 2, minus 2, here it is 1, minus 3, 0. So you plot these points in the Cartesian plane. Just have shown the table, remember, but you can do it directly. You know what should be the graph of this. It's a union of two rays at minus 3. ये आपने 11th में किया है, आप जानते भी हैं, and you should know if you have not at clear to you, you must clarify. We did it in 11th number of times, and earlier also I have mentioned this. X-axis, y-axis. Okay. You know that this becomes 0 at minus 3. So suppose this is 0, let me take minus 3 here. Okay. So it would be union of two rays at minus 3. So one ray would be over here and the other ray would be this. The other ray would look like this. Fine. The other ray would be this. You can just plot the points without writing these points. This is a very standard function. This is the graph of this function. This is positive ray, this is negative ray. That union of two rays at minus 3, where this becomes 0 at minus 3. If you consider this function y equals to modulus x, this is the union of two rays at origin. This you know, because here at 0 it becomes 0 and so on. Here where this becomes 0 at minus 3. So one ray over here, the other ray over here. That's one thing. Here one more thing you are asked in this question, evaluate this. Now such questions you did number of times in definite integral. I'm sure you can do it. If you are unable to do this, that means you are not clear with definite integrals. How will do the modulus questions? You look at where the modulus becomes 0. Where the modulus becomes 0 at minus 3. So you will split this integral at minus 3. Minus 6 to minus 3 and minus 3 to 0. Okay, ab jante here one integral will be positive, the other one will be negative. First integrally always negative hota hai, remember. So this and here this will be positive. Now I don't think so you need my help. Just linear function, integrate it, write carefully upper limit minus lower limit. Integrate this. X square by 2 3x, x square by 2 3x, and then upper limit minus lower limit, and simplify, I'll get the answer. Fine, it's just a question of definite integral, remember. Fifth question. Find the area bounded by curve y equals to sin x, our standard trigonometric function sine, between x equals to 0 and x equals to 2 pi. Now here you see here question sounds like the question number 1. इसके जैसा ही आप देखो. Area bounded by the function between 0 and 2 pi. There you had the same question. Area bounded by y equals to x square between 1 and 2. But here if I do like this, like the first question, 0 to 2 pi y dx, and if I write 0 to 2 pi sin x dx, this would be wrong, remember. This is not the right way of doing this question. Why? If you remember theories, here the graph of the sine function cross the x-axis between 0 to 2 pi. You know the graph very well. So if I just draw the graph here of sine function, you know it. Let me just remind you, this is x-axis. Here this is y-axis. Okay, graph starts from 0, you know, passes through the origin here. So 0, at pi by 2 it becomes 1, at pi it is 0, at 3 pi by 2 minus 1, and at 2 pi it is again 1. So if this is 1, then the graph is like this, you know it. Right? So you are asked for this, remember. So have you noticed here graph intersect the x-axis. It is not on the same plane. Some portion of the graph is in the upper half plane, some portion of the graph is in the lower half plane. Right? So in that case, you cannot straightforward integrate from 0 to 2 pi. That was not happening in the first question. You look at it, the first question, see the graph. You will notice that the graph is on the either side of, it is just on one side of, coordinate axis. So, आप कैसे integrate करेंगे? 0 to pi and then pi to 2 pi. So here area, that is A, equals to modulus of I1 plus modulus of I2 individual, and then we add them. Right? I've already discussed this portion in theory, you know it. Just go back to theories, beginning session, first session. You'll realize what is I1 there? 0 to pi. It starts at 0. 0 to pi sin x dx. Right? What's the integral of sine? You know, minus cos, and limits from 0 to pi. So here you have cos pi minus 1, cos 0 is here 1. So inside the bracket you will get the minus 2. So you'll get the 2. Just check why minus 2. What about I2? From where to where? Pi to 2 pi. Integral of sine x. What's the integral of sine? You know, minus cos. Limits from where to where? Pi to 2 pi. Put upper limit cos 2 pi. You know it is 1 minus cos pi minus 1. So you will get again minus 2 here. So therefore area equals to इसका मॉड्यूलस 2, इसका भी मॉड्यूलस 2. remember मॉड्यूलस करना है आपको individual. Here minus 2, here 2. So we'll get the final area equals to 4. Got it? Or you could have done like this. Get the area in the first quadrant and multiply with 4. That way you could have done it, remember. That's also another way of doing. Right? Or alternatively, you could have done like this. What you would have done? Get the area in the first quadrant. So area equals to here 4 times integral 0 to pi by 2 sine x dx. That this is also right. You can just check that this would be 1. So we'll get the 4 here. This is another way of doing the same question. याद रखो साइन फंक्शन का एरिया एक क्वाड्रेंट में 1 यूनिट ही होता है. You just remember this. In MCQ it might be useful. Area of sine or cosine in one quadrant. कोई भी quadrant आप ले लो. In one quadrant it is 1 unit. In one quadrant, area of sine or cosine in one quadrant equals to 1 unit. Right? In MCQs you can write directly. अगर एक क्वेश्चन MCQ में पूछा है तो 0 to 2 pi कितना क्वाड्रेंट हुआ? 4 quadrants हुआ. 4 quadrants में area would be 4. That's what you are getting here. But this I did subjective point of view, remember. Got it? याद रखो area of sine or cosine function in one quadrant equals to 1 unit. अगर एक क्वेश्चन में यहाँ पे मैं सपोज 0 to 10 कर दूँ, okay, same question like this. Same question, area of y equals to sine x from x equals to 0 to x equals to, let me write 10 pi. Okay, so 10 pi means how many rounds around the unit circle? 1 round means 2 pi, or एक round means 4 pi, और एक round means 6 pi. So how many rounds? कितने round हो गया? 5 rounds हो गया. 5 rounds around the unit circle, right? Okay, now 1 round means 4 quadrants. तो एक quadrant में 1 unit होगा. Is it? Area of the sine function. So एक राउंड में 4 यूनिट है. कितना राउंड्स है यहाँ पे? 5 राउंड्स. So आंसर विल बी 20. So area of the sine function from 0 to 10 pi is nothing but what? 20. That way you can think of. Understood what I'm trying to tell you? Is this clear to you? आप इसका ग्राफ देखेंगे. Just I'm showing you. It would be like this only. It goes on like this. But in 0 to 2 pi it is 4. इसे कितने राउंड्स? Oh, sorry. So 0 to 2 pi means 5 rounds हो गया. एक राउंड में 4 क्वाड्रेंट, so 4 यूनिट हो गया. 4 into 5, 20. Right? That way you can think, remember. Okay, but keep this much in your mind, remember. Area of sine and cosine in one quadrant is 1 unit. Okay. Now let's go to next question. Next number, 6th question. Area enclosed by the parabola. Okay, so y squared equals to 4ax. This is a standard parabola, you know. And line y equals to mx. So this is the area between line and parabola. Copy of question number 2. Very standard question. Next देखो आप 7b इसका कॉपी है. क्वेश्चन नंबर 2 वाज आल्सो दिस. प्रोसीजर सेम है तीनों तीन में. फॉर्मूलाज एंड इक्वेशंस आर डिफरेंट. मेथड तीनों तीन में एक है. सेकंड विच वी डिड 6th एंड 7th, तीनों तीन क्वेश्चन में क्या है? पैराबोला एंड स्ट्रेट लाइन ही है. व्हाट विल डू? एरिया बिटवीन टू, सॉल्व द इक्वेशंस, गेट द इंटरसेक्शन पॉइंट्स, लिमिट्स आ गया, एंड वन फंक्शन माइनस द अदर फंक्शन, सम इज ओवर. Got it? So here just I'm showing roughly here. This is symmetric about which axis? X-axis. You know which variable is free from origin? Squared x. So it is around x-axis. ये कौन सी लाइन है आप जानते हैं? दिस लाइन पासिस थ्रू ओरिजिन, इट वुड लुक लाइक दिस रफली, ऐसे दिखेगी ये आप जानते हैं, लाइक दिस. सो इंटरसेक्शन पॉइंट, एक तो ओरिजिन ही आएगा, आप दोनों को सॉल्व करेंगे. दूसरा कौन सा पॉइंट मिलेगा? ए वाला. यू विल गेट दिस पॉइंट राइट थ्रू द इंटरसेक्शन. ओके. So just for your information, I'm solving these two equations. Solving the equations. So I'll put the I'm interested for x, remember, तो y को हटा दो आप, y का वैल्यू यहाँ से रखो. So m square x square equals to 4ax, y square m square x square. Okay. So I'll take x common from this two. So m square x minus 4a equals to 0. So either x is 0 or you make the x as a subject of the expression here. कितना होगा? 4a by m square. So ये आपका दूसरा intersection point आ गया. So 4a by m square. Fine. Please check this carefully without making mistake. I'll just place the value of y here, m square x square, taking x common. So here m square, here x बचेगा, यहाँ पे 4a बचेगा. So either x is 0 or this is 0. So what is x from this? 4a by m square. So limits मिल गई, आपका ये required region है, ये आप जानते हैं. So here area a equals to modulus of I, where I is from where to where? Integral from where to where? 0 to 4a by m square. One function minus the other function, fx minus gx, around which axis? x-axis. So दोनों में से आप क्या निकालेंगे? y निकालेंगे. One function minus the other function. Order important नहीं है, remember, कोई भी function ले सकते हैं पहले. तो इसमें से y निकालो. आप फर्स्ट क्वाड्रेंट में कर रहे हैं तो पॉजिटिव स्क्वायर रूट ही आएगा. 0 to 4a by m square. व्हाट इज y फ्रॉम दिस? 2 रूट a, ये तो कांस्टेंट है, इनटू रूट x. दिस इज कांस्टेंट, खाली इतना ही आपको इंटीग्रेट करना है. माइनस mx. नाउ आई एम श्योर यू कैन डू इट. आई विल नॉट डू फर्दर. y निकालो फर्स्ट फंक्शन में. y dx होता है, ये y dx ही होता है. गेट द y फ्रॉम दिस. व्हाट इज y फ्रॉम दिस? 2 रूट a एंड रूट x. एंड ये पॉजिटिव होगा क्योंकि आप फर्स्ट क्वाड्रेंट में बात कर रहे हैं, यू नो. एंड व्हाट इज y फ्रॉम देयर? mx. इंटीग्रेटेड, राइट केयरफुली, अपर लिमिट माइनस लोअर लिमिट, सो यू कैन गेट द आंसर. यू विल गेट द आंसर. फाइन. ओके. Seventh I'll not do because it is again about parabola and straight line. I'm sure you can do it. It's not a big task for you. Okay. Question number 8 and 9th. Come to 8th number as well as 9th number. See, read these two questions. Question number 8. Find the area of the smaller region bounded by ellipse and this line. Second, 8th and 9th, you see same question. इसमें स्टैंडर्ड एलिप्स दे दिया, जनरल इक्वेशन ए बी के फॉर्म में. वहाँ पे लाइन है, यहाँ पे स्टैंडर्ड लाइन है. ओके. सो आई विल डू वन ऑफ दिस टू. ओके. आई थिंक आई विल डू 9th. फिर आप देखेंगे तो बोथ आर जस्ट सिमिलर क्वेश्चन. सो फ्रॉम 8th and 9th, these are just same questions. So I'll be doing 9th question here. Okay, so here ellipse is given by x square by a square plus y square by b square equals to 1. And what about line? You know that this is very standard line making a and b intercepts with the two coordinate axes. Fine? Okay. So I'll just draw the diagram, you will realize. Okay, so let's see this. I'm just drawing the rough graph. You know ellipse, it's an oval shape. You know here this is a comma 0 and this is 0 comma b. That much you know. This is a standard straight line having A intercept with x-axis and B intercept on the y-axis. So if you just recall 11th standard, this line would be like this, remember. This is the exact graph of that line. It would be this line. You know it, right? It's not any random line, remember. It has small a intercept with x-axis, small b intercept with the y-axis. Okay, so now what is asked in the question? See the question here. What do you want? Area of the smaller region, remember. So this is the area. I mean, you want the area of this region. So from where area starts? Here. What's the value of x here? 0. Where the area ends? Here. What's the value of x here? A. 0 to A. And it's between ellipse and straight line, right? Area between these two curves. So it's like that earlier questions only, between two curves. Formula is fx minus gx. Okay. Even here no need to solve because you know intersection points, because both are very standard functions. Just you need to get the y from this. Y square minus b square equals to 1 minus x square minus a square. So what is y from this? You have root of a square minus x square. Here b by a. This is positive q because it is in the first quadrant, remember. And you make the y as a subject of the expression here. So b by a equals to 1 minus x by a. So y equals to again b by a into a minus x. This is one function, this is another function, remember. Then fx minus gx. Your sum is almost over, remember. Okay, so here area, that is a, equals to modulus of I, where I is integral from where to where? Area starts from here, it ends here, 0 to a. And it is between two functions. So you know this is very well known standard formula, fx minus gx. It's around x-axis, remember. You could have taken around y-axis also. So limit hoga 0 to b. And here you would have dy. Then you need to make the x as a subject of the expression. X as a subject of the expression. That way also you could have done it, remember. Okay, now y dx, y dx. So get the y from there. So integral 0 to a. What is y? You did it now. That is b by a into root of a square minus x square minus y. What is y? b by a inside the bracket a minus x and then whole dx. Okay, now I'll just integrate this. You can take b by a common before I integrate it. Let's take b by a common here. So what will get inside the integral? 0 to a root of a square minus x square minus a plus x. Okay, now I'm just integrating this, which is very well known standard integral. Again, not a big task for you, you can also do it. Try yourselves and then compare with your answer here. B by a outside as it is. You know a square minus x square is very standard formula. X by 2 into the same expression plus a square by 2, constant first, so answer in form of sine inverse. Sine inverse x by a minus integral of a is x, ax plus x square by 2, 0 to a. I repeat, x by 2 into the same expression plus a square by 2 sine inverse x by a, integral of ax, and x is x square by 2, you know. Now just upper limit minus lower limit. So b by a, put upper limit. So here a by 2, a square minus a square 0. A square by 2, Sine inverse a by a. What's the sine inverse a by a? Sine inverse 1, pi by 2. Here a square plus here a square by 2. This is upper limit. Minus, instead of x you put 0. 0, sine inverse 0 is 0. This is 0, 0, 0. All terms are 0, remember here. Just put x equals to 0, you will notice. Okay, now let's simplify. We are just simplifying this. So b by a as it is here. This is pi a square by 4 minus, here you are left with a square by 2 again, minus 2a square plus a square. You can find a square common, so pi a square by a, pi by 4 minus 1 by 2. So here you are left with just ab. What about this? This is pi minus, if I take 4 LCM, by 2 minus 2 by 4. That's required integral. Pi minus 2 by 4. This is your I. And therefore, this is always positive. So ab into pi minus 2 the whole by 4. That's area. How will do the previous question? Same procedure, remember. Exactly same procedure, right? There you have, instead of AB, 3 and 2. You just put A equals to, A equals to 3 and B equals to 2. You will get the answer to the previous question.